Welcome to your video on your review for your linear equations test. We will go through each one of these sections that resemble the types of problems that you will see on your linear equations test. So on your note sheet, you'll notice the very first topic that you have is graphing a line. And we had three different methods that we used to graph a line. The first one of these methods that we're going to discuss is a table of values. So if you see the equation y equals a negative 2x minus 1, the first thing we have to do is to make our table. If you remember, our table has three different categories in it. On the far left, we have to pick various x values. In the middle, we actually write down the equation that we are dealing with. And last but not least, we find out what our y value is. So we're ultimately going to make ordered pairs that we're going to graph on our coordinate plane. So you can pick any values you want for your table of values. Typically, there's a pattern that we always go. We pick our -2, our -1, our 0, our 1, and our 2. So now this is where you will need your calculator. So please get your calculator out, and we are going to plug in each one of these numbers. So we plug the -2 directly in place of the x. And you'll notice where the x was in the equation, we put parentheses around it and plugged our number actually in. And now all we have to do is figure out what this answer actually is. So you have -2 times -2 is a +4 minus 1. We end up with a 3 in that category. So our y value is a 3. We can now go on our coordinate plane and go 2 to the left because it's negative, and then 1, 2, 3 up. And we have our first point that would make our line. We have to now continue to do this for each one. Now we plug the -1 inside the parentheses and solve this. So we have a -2 times -1, which is a +2. +2 minus 1 gets us a 1. So we have our second point now. That is a -1, 1. -1, 1 gets us our nice second point here. Now, typically what we want to do is we want to pick and do at least 3 of these to make sure that the pattern that we see is going to continue to develop. So -2 times 0 is 0, minus 1. Now we end up with a -1. So our third point is a 0, -1. You will notice now that each one of these points is going down 2 and 1 to the right. So if we continue with this pattern, the next value that we should end up with is a -3, and then we would end up with a -5. And if you want, plug these in, check those out to make sure, but I'm going to go over and I'm going to graph. So 1, -3 here, 2, -5, and now, just like before, we can use our nice line tool that we have, and we can make a nice straight line with your ruler, protractor. The big thing that you are going to want to make sure that you do is on here to make sure that both of these have arrows on the ends of them. So review on your table of values. The second method that we went through and tried was our intercepts. So you'll remember here, when we are trying to find our x-intercept, there was one really big hint there. Your y is always 0. So we know that in this equation, we can plug a 0 in place of the y and now solve. We hopefully notice that those go away. 3 times 0, that -3 times 0 is just 0. So all we have is a 2x that's equal to 12. We divide both sides by a 2, and we wind up with our x that's equal to 6. So we have our first intercept that will actually be at 6, 0. So 1, 2, 3, 4, 5, 6, 0. I have my first point down. My next point here with my y-intercept, hopefully we can pick out what information we're going to have to do, because now we know instead of our y always being equal to 0, our x is always equal to 0 in this case. So when we plug that in, we end up with a 2 times 0. minus our 3y, that is equal to 12. And now we have to be real careful here because the 2 and the 0 cancel out, but we still have a negative 3y that's equal to 12. We divide both sides by a negative 3, and we wind up with our y equal to a negative 4. So when we write this as our final answer, we know that is our y coordinate, so we have a point 0, negative 4. So I'm going to go and graph that on my coordinate plane as well, and I have 2 points. I have enough to make my lines. I'll put my line tool in here. I'll go back and I'll finish my line off to make sure it looks good with arrows on both sides. It's nice and straight because well, hopefully you used a ruler or protractor. There is one more method, and it's our slope-intercept form. So hopefully as you're looking and hearing those words, there's some stuff that pops back into your mind. This is our wonderful equation, y equals mx plus b, where we know that the m is our slope. We know that our b is our y-intercept. And both of these two pieces of information are going to help us create a graph. So based off of what we have, we see with this equation that our slope is a negative 1/2. It's the number that is directly before the x. This is how we figured out the slope. And knowing that, if you need a little bit of a helpful reminder, that means the slope in this case means that you go down 1 and you go to the right 2 spots. But you may wonder, well, where do we have to do that from? Well, it's whatever number is after the x. So in this case, our b value is a 4. And I'm not going to put just a regular 4. I'm going to put my 0, 4. So I know that this is the point that I have to start my graph with. So we have to plot this point, our 0, 4, first on the graph. And from here, we can use the slope. So I go over to my graph, 0, 1, 2, 3, 4, and I have my first point. So now from here is where I use my slope, and I go down 1 to the right, down 1 to the right, down 1 to my right. And once I do that a few times, I can again use my ruler, my protractor, whatever tool you have to make a straight line, and I can now finish that out by putting all of those markers on there. And you'll see that we figured out 3 different methods, reviewed 3 different methods on how to graph a line. So if you want, you can stop the video at this point and you can start working on the day 1 review. If you want to keep going, then we are going to start reviewing for the day 2 part of our review for our linear equations test. So what this review is all about is slope. So we found slope from a few different fashions, and one of them is from a graph. So the first thing that we have to do is that we need to find, and in this case, we need to find 2 nice points. And on this graph, you'll notice that this line goes through a lot of different parts. And the 2 nice points that we're going to pick, we could pick a lot of points. One of them I always like to look for is a point that is actually on my intercept. So I have one nice point, and if I go to another nice point, I'm going to go down here to the point 2, negative 2. So I have now done step number 1 based off of this graph. The second step that we want to do is we want to count our rise over our run. And when you hear the rise over run phrase, hopefully you remember the parts that are going to have a positive and a negative answer. So if you are going down, this line is going to have a negative slope. If you are going to the left at all, you will also have a negative slope. So be very, very careful. And as we look at this particular graph, hopefully you realize right away that this slope, no matter what we actually do for the rise over run, has to be negative. Okay? And in this case, we know it's going to be a fraction because slope in some way, shape, or form is always a fraction. So now our third step is, well, to reduce the fraction with whatever we need to, if we actually even need to reduce. So in this case, we're counting our rise over run. We go 1, 2, 3. Our rise in this case was 3. Our run, our sideways was 1, 2. So we know for our final answer, we are going to have a negative 3 over 2, our negative rise over our run for our final answer, finding slope from a graph. The next part is to find slope from 2 points. And plain and simple, there's one equation, y2 minus y1 over x2 minus x1. You've used this equation a lot so far during this unit, especially on your last quiz. So what we're going to do now is make sure that we label each one of these the right x1, y1, x2, and our y2. Remember that x always comes first. And as we do this, plug each one of these values in. We have our y2 that has to be first. So we put our negative 5, and we always have to put a subtraction sign directly after writing down the number. So we have our negative 5. We minus our y1 in this case, which is just a regular 4. I'm going to now all divide it by, and I'm going to put my x's on the bottom. I have my 3, I have a minus sign, and now I need to subtract, in this case, my x1, or a negative 3. So let's now simplify my numerator, the top of my fraction. Negative 5 minus 4. Hopefully you still have that calculator on your desk as you're taking these notes, because you could go through and make sure you get a negative 9 for that answer. And last but not least, if we're looking at that bottom, hopefully there's something that sticks out to you. You have 2 negatives directly next to one another. They come right in line with one another. So we now need to actually change that to an addition and add these together. So some of you are looking at this answer of a negative 9 over 6 and thinking, I'm done. But we can reduce this into lowest terms. So what number goes into both of these? Hopefully you see that we can divide both by a 3. We now wind up with our final answer of a negative 3 over 2 for our slope. So now you have just done the second method on how to find slope. And we're going to finish with a word that means the exact same thing as slope. It's a rate of change. So rate of change is the exact same thing as finding a slope. There's, I would say, 2 things that we have to be careful to always check and remember. Always look for units and labels. Be sure when you have a rate of change question, if you see those words, you know you have to put a label or some type of units with it. And always be real careful of the scale that is on each graph. They may not always go up by 1. So just double check that. So always look these over when you are coming to a rate of change question. So in this case, well, don't do a graph. So we're doing the same steps that we were finding for our slope from a graph. I want to pick 2 nice points. I have 1 point there and another point here. I'm going to calculate my rise over run. So it's a 2 over a 1. So in this case, what I just found is that my rate of change is equal to a 2. But now this line is going down, so I know it's a negative 2. So I need to make sure that not only do I put the negative sign, but I need a label. We always are putting our y's on top over our x's. So that means we are losing 2 feet per, and then what's the x label in this case? Hours. So we're losing 2 feet every 1 hour that actually go by. And if we were asked to write, I don't know, a sentence that explains what this means, it means that the y-intercept actually tells us that the water level starts at 14 feet, and this is your y-intercept, and the actual rate of change means that we are losing 2 feet every hour, and that is a description that says our rate of change. So not only do we have to calculate the rate of change, but we also had to describe what some of the information meant on our graph. So a couple reminders on slope. Feel free to stop the video at this point. You now have enough information to complete day 1 and day 2 of the review. All right, for those of you that are looking now to complete the last day of notes, our day 3 notes, this is the information that you just took a quiz on before break. So our goal now is to go through and review not only the types of lines that we have, but also how to write equations for these lines. So you'll notice that when we're finding equations for lines, the method and how the equation looks is different based on what type of line you have. So a diagonal line is one that either goes up or it's one that goes down that has a positive or a negative slope, not horizontal and vertical, so it actually goes at an angle in some way, shape, or form, and there's an equation. So we need to start with our y1, y minus y1 equals our m, and then times our x minus x1. And then we solve this equation to equal the equation that we all love. Our last step here would be our y equals mx plus b. And this equation should always be our final answer. So now that equation is our final answer. Anytime we have a diagonal line, but we have a few different types of lines as well. A horizontal line will always have the same exact equation of y equals y1. Now be careful. Remember, when you're looking at your ordered pairs, the y1 is going to be the second number that you have in your ordered pair. And if you recognize that right away, there's a few pieces of information that you know about this graph. Your slope is 0. And you also know that all of your y coordinates are the exact same. We could list 5 different ordered pairs and the y value would be the exact same. So on your graph, your line in some way, shape, or form will go through only your y-axis. On that same note, actually, it's the almost exact opposite because now we have a vertical line where we have an x equals an x1. So now, again, that friendly reminder, when you have an x and a y, your x1 is going to be the very first coordinate that you see in your ordered pair. There's also a few pieces of information that we know about this. We have our slope with every vertical line is undefined. And instead of all of our y coordinates being the same, now all of your x coordinates are going to be the exact same as well. And if we make a little sketch about what our vertical line looks like in some way, shape, or form, it's going to be a line that goes through only your x-axis. So this is the background information so that now we can actually write our equations for lines. So if we're given a graph and we want to write this equation, the first thing that we need to find, and well, we need to remember that our final answer has to be in this form, y equals mx plus b, where we know that our m is our slope and our b is our y-intercept. So step number 1, well, let's find out these 2 pieces of information. Let's first find our b value, find our y-intercept. And in this case, on our graph, where does the red line cross the y-axis? Well, there's only one point, and that's at 3. So for this particular example, we found that our b value was equal to 3, and we need to be really careful here, because if we're writing it, we know it has to be written as a 0. I don't know why I wrote 4, 0, 3 that we actually have here. Okay, the second piece of information now, well, after we found our y-intercept, we need to find our m value, or our slope. So we count our rise and run, we pick another nice point. I'm just going to pick my other intercept that I have here, and I'm going to go 1, 2, 3, and 1, 2. So if you notice, this line is going up, so our slope is going to be a positive number, and then the fraction is going to be the rise part. We went up 3. The run part, we went over 2, so our slope is 3 over 2. So our final answer now, we have to plug these two pieces of information in. Y equals, we plug our m directly before the x. So we have a y equals 3 over 2x, and plus, this is the only spot now that we don't use the parentheses. We write that number of a positive 3, that was our y-intercept, and we have our final answer for the very first example. The next type of equation that we're going to have to write is when we're given 2 points. So the very first thing that we want to do is to use our y2 minus y1 over our x2 minus x1. So if I'm labeling x1, y1, x2, y2, as I go through, let's actually plug some of these numbers in now. So I have a 2 minus a negative 1 all over a 1 minus 2. I simplify both of these down. I see 2 negatives right next to one another, so I end up with a 3 in my top. And in my denominator, I end up with a negative 1. When I divide these out, I ended up with a negative 3. So I found out that my slope in this case is a negative 3. This is my m value for my next step. And well, you may ask, what is that next step? That next step is using our other equation when we're trying to find the equation for our lines. Our y minus y1 equals our m times our x minus x1. So we can plug all the necessary information in here as well. We plug our y minus our y1 value happens to be a negative 1. And right away, I'm going to make that was into a plus sign so we don't get confused with that at all. In place of my m, I put my negative 3. And I finish this out by saying my x minus my x1, which is a regular 2. So the first thing that I want to do after rewriting some stuff is to use the distributive property on the right-hand side. Negative 3 times x is a negative 3x. Negative 3 times a negative 2 ends up being a positive 6. And now for my last step, I can subtract 1 from both sides. So I end up with a y equals a negative 3x plus 5 for my final answer. And I know I have my slope and my y-intercept if I needed it. Okay, 2 more left here for the different ways. So we have a few different types of problems here because now it's from a description. So that means we're going to give you a piece of information and you have to try to write your y equals mx plus b. So, well, what does this information give you? In A, it says the line contains a negative 8 and a 5, which is an x1 and a y1, and has a slope of a negative 1/4, which is our m value. Well, anytime you have a point, we need to use our point slope form or our equation with our slope and a coordinate. So we plug the necessary pieces of information in again. Y minus our 5, that's equal to our negative 1/4, and then we have an x minus a negative 8, which turns it into a positive. Now, I would really recommend making sure you have that calculator out on your desk and that you are actually putting this into your calculator so you know how it works. Because as you're going through, we need to do the distributive property, negative 1/4 x, and you multiply a negative 1/4 with a positive 8, and you are going to wind up with a negative 2. Check your calculator to make sure you got that same answer. And now as we go through, we can add 5 to both sides. So we get our final answer of a negative 1/4 x plus 3, and we've simplified that into our lowest terms. Right? The second equation that we have from a description is when it tells us now we have an undefined rate of change and it passes through the point -6 and 10? Well, there's a huge hint there. Right away, when you see that undefined rate of change, which means you have an undefined slope, that means you have a vertical line. So if we check the top of our note sheet here for a vertical line, it gives us the equation x equals an x1. Well, we know we actually have an x1 value. That x1 value is a -6, and we can simply write that down, no work needed, and we are done with our equation from a description. And now, last but most certainly not least, your equation from a table of values is the exact same as if you have the job to write an equation from 2 points. We can pick any 2 points that we have here. I'm going to pick the 2 numbers that don't have any negatives. So I have the point 0, 3. I have the point 1, 6. So I have an x1 and a y1. I have an x2 and a y2. And what I need to do is I need to find my slope. So to find my slope, I have my y2 minus y1 over x2 minus x1, which for me leads 6 minus 3 all over 1 minus 0. You end up with a 3 over a 1, or we found that our slope is 3. So we've now figured out our first step, and now we have to plug our points in. Y minus your y1, which happens to be our 3, equals your slope, which is the number we just found, that was a 3, x minus our x1 value. That x1 value is that big fat 0. So as we go through, we use the distributive property on the right-hand side, 3x, and then we have a 3 times 0, which gives us nothing. And on the left-hand side, we still have that y minus 3. Our goal is to get that y all by itself. We add 3 to both sides, and we wind up with our final answer of a 3, y equals 3x plus 3. So now you have enough information to do all 3 days of the review, which you will be working on in class for the rest of this week in preparation for your test. Good luck.